Morning, Algebra 2 students. So here's my first of two videos this week. This one is called Exponent Rules and Rationalizing with Exponents. So we're going to go through quite a lot in this video, so feel free to pause, slow down, and move through this how you need to in order to learn everything associated with the worksheet. So first we come on in. This is just a reminder of our exponent rules. So a power to a power, am to the n. That's multiplication. If you have a to the x times a to the y, you add these together. If you're dividing, you need to subtract. If you have something to a negative power, this is something that's new that you guys have been messing with a little bit. If it's to a negative power, it actually just goes on the bottom of a fraction. This is what we're going to be working with today. So if I have something to the y root, a to the x power, but to the y root, so it could be cubed root, fourth root, things like that, it becomes a fraction. And then lastly, we know that all of our powers to 0 is just 1. All right, so first we're just going to start by using some of these exponent rules, and I have 3 examples we're going to go through right here. So the first one reads, b cubed times b squared times 3b to the 5th. And that is going to be, well, I'm multiplying here, so I got to add these exponents. So that's going to be b to the 10, and I don't have anything to multiply the 3. 3b to the 10. Because we are multiplying, I add these. All right, the next, 2b cubed times b to the negative 4. Well, I'm multiplying, so I'm going to add these. 3 plus negative 4 would be 2b to the negative 1. I can't have negative exponents here, and a negative exponent tells me that it goes below a fraction bar. So this would become 2 over b to the first. If you want to include the 1, you can. You don't have to. All right. Can you see that okay on the camera? Okay. The last one, we're going to need a couple different colors for. So the first thing I'm going to do, because I have this whole fraction, 2x squared over 3x to the negative 2, okay, and I have that all to the power of 3. Well, if I have this all to the power of 3, I need to multiply here. So I'm going to distribute this 3 to all the powers and multiply. So this becomes 2 cubed. Well, 2 times 3 is x to the 6th. 3 cubed. And 3 times negative 2 is x to the negative 6, because I'm multiplying a power to a power. Now from here, I can do some rewriting. 1, if this exponent's negative on the bottom, this whole thing comes up top. 3 cubed is 27. 2 cubed is 8. So now I have x to the 6th. This x came up, and that became a positive x to the 6th, because when you go from bottom to top, it becomes negative to positive. And now I'm multiplying those, so I add these together. Final answer, 8x to the 12th, all over 27. There's a little refresher on using exponent rules, okay? You will be asked to do that in the first part of your homework. All right. Let me erase this real quick. Okay, my wife's zooming in on my cat. That's great. I also attached an exponent rules document or picture to the Google Classroom post. So feel free to know that you have access to that. It'll also be in your notes that I post on Thursday, because you know I like to post my notes a couple days after the videos. Okay, the next one is if we have a fractional exponent. So let's move over here. This one is actually pretty easy. So I have n All right, so I have the square root of n cubed equals 512. First, I'm going to use this to rewrite as a fraction. So I know that this is going to be the bottom of my fraction, that's going to be the top. This will be the bottom, that will be the top. So I have n to the 3 over 2 equals 512. Then from here, to cancel out a 3 over 2, I have to flip it and raise this to the 2 over 3 power. Because when I multiply, cancel, 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 cancel. Well, if I raise it to that power on this side, 2 over 3, so whatever the opposite, just flip that, raise both sides to that power, and you can do this on your calculator. From here, you just type in 512, caret button, that little caret button, the one that looks like this. On your calculator, type 512, caret, and then parentheses 2 divided by 3. And you can do that on Desmos, you can do that on a graphing calculator, you can do that however you want. When you type that into your calculator, you're going to get n equals 64. There's a few problems like this on your worksheet. I write in the directions, use your calculator, just to remind you, okay? The last one that we're going to be working with is one that's going to provide you like with a lot of skills here, and this is the one that directly relates to logs. So I'm going to erase this, and we have about 3 or 4 examples here that we're going to go through. Okay. And this is how you get bases to be the same and things like that. So the first thing I got is just this problem, 4 to the x equals 64. Oop, not 6 to the 4th, 64. So I have 4 to the x equals 64. So 4 to what power is 64? Well, here's how you go about these. Well, I know that 4 times 4 times 4 equals 64, also known as 4 cubed. So I'm going to say 4 to the x equals 4 cubed, because I want these to match. Once those match, I can drop them, and I would just be left with x equals 3. That's a really straightforward example. Let's talk about one that's maybe a little bit harder. Example 2 here. Here I have 3 to the x equals 9 squared. Well, I need this to match this. So 9 is 3 to the what? 9 is going to be 3 to the x equals, well, 9 is 3 squared. This 2 comes down here. This changes from a 9 to a 3 squared. This is where our exponent properties come into play, because I now have to multiply those. So I would get 3 to the x equals, well, 2 times 2 is 4. 3 to the 4. I can drop those, and x equals 4. So you got to get pretty good at changing your bases here. So even though this is 9, I got to make sure that I'm writing it as like 3 squared or 3 cubed or whatever it might be. Okay? Couple more. These things are going to get progressively harder. As you go through this, make sure you're pausing the video, double checking, making sure you understand how I'm coming up with stuff. Like always, email me if you have questions. Also, just a plug, we only had a few people for Zoom last week. If you're struggling on this, I will be hopping on a Zoom on Friday. Okay. Next one. Even trickier. 1/4 equals 2 to the x. Okay, because this is my variable here, I need my base to be 2's. So I need to take this 4 and change it into a 2. Well, I know that 4 is 2 squared. So I'm going to put that right there, okay? 1 over 2 squared equals 2 to the x. Well, this isn't a fraction and this isn't in a fraction. So I gotta make sure that this comes up here so that way we get rid of our fraction. Like we said before, when you move that up, this exponent becomes negative. If you move it down, it becomes negative anytime you switch it over. So I have 2 to the negative 2 equals 2x. Perfect. Those match, and I would get negative 2 equals x. All right, just a few more examples we got. We got 2 more examples. This one, 4 to the negative 2x plus 1 equals 4 to the 3x. These are nice ones because your bases match, so you can cancel, and I would get negative 2x plus 1 equals 3x. Add my 2x over. 1 equals 5x. Divide by 5. Divide by 5. 1/5 equals x. All right, and then very last example that I have over here is this one. 5, I have 2 to the negative 3x equals 16 to the x. Okay. Sorry, 2 to the negative 3x. 2 to the negative 3x plus 2 equals 16 to the x. Well, my base has to be 2. You always choose the smallest number, the one here for your base. I know that 2 times 2 times 2 times 2 equals 16. So that would be 2 to the 4th equals 16. So this changes from 16 down to 2 to the 4th to the x equals 2 to the negative 3x plus 2. I have to multiply these. So I have 2 to the negative 3x plus 2 equals 2 to the 4x. And then those are the same. I cancel those. Negative 3x plus 2 equals 4x. Add 3x, add 3x. Keep it moving. 2 equals 7x. Divide by 7. Divide by 7. X equals 2 over 7. Okay, woo! That was a lot in like one short video. Essentially, with the worksheet, you're gonna practice some with your exponent rules. Okay, just to refresh you on those. It's probably been a while since you've gone over exponent rules, so make sure that you're using those when you're solving these, okay? And then you'll move into using these. Then the ones where you use your calculator that we went over, just the one example, those are pretty easy. Okay, that's called rationalizing. And then you move into rationalizing and solving over here. So I would encourage you to slow down on those last 5 equations and make sure that you are taking notes on this. Like always, if you have questions, email me. If this video wasn't super helpful, go to Khan Academy and they have videos on rationalizing exponents there that are pretty straightforward. But your work this week has just a worksheet on this video. Hope you guys are staying safe and doing well. Look for my other video later this week. Bye.